Hey guys, I'm Steven from Hard Artifact Media, and in my last video that I did, I went over the motherboard and the different types of connections and things you'll find on it. And one of the things I went over, or quickly went over, was the VRM, the voltage regulator module. And in this video, I kind of wanted to do a quicker rundown, a more in-depth rundown of the VRM. But before I can talk about the VRM, I need to talk about why we need the VRM. And to come to the why, we need to talk about the power we're getting from the power supply. Now, the power supply only provides three constant voltages, and that's 3.3 volts, 5 volts, and 12 volts. Now, the 8-pin connector right there, it's taking 12 volts and sending it straight to the CPU. And the CPU can only take anywhere between 0.5 to 1.5 volts. So obviously, we don't want 12 volts going straight to the CPU, or that's just going to fry the chip. We don't want that. That's where the VRM comes into play. And the VRM is, as you can see, made up of 4 different components. You got the PWM chip, the MOSFET, the choke, and the capacitor. Now, the PWM chip here, or the pulse width modulator, what this does is it regulates the drivers that are connected to the MOSFETs that allow the MOSFETs to do their thing. And what the MOSFETs do is they will turn on and off at a rapid pace to allow short bursts of the voltage or the current coming from the 12 volt into the rest of the VRM, the chokes and the capacitors here. And it takes the 12 volts, basically chops it up into a bunch of smaller voltages, and then sends it on to the chokes and the capacitors. And the chokes and the capacitors, what they do is help smooth out that choppiness into a more smooth and stable current that then is transferred into the CPU. Now, I have a diagram here that is a lot simpler than just, electrical diagrams. And as you can see here, you have the power from the PSU. It's going down, it's going straight into the MOSFETs here, and then into the chokes and the capacitors onto the CPU. So as you can see here, the PWM is connected to the drivers that are connected to the MOSFET. So PWM is sending signals to the drivers to be like, hey, I need you to start turning on and off real rapidly. As you can see here, the red line is telling the low FET to turn on, and then the high FET to turn off, and then vice versa, really fast. And then it's taking that power going from the PSU into the high and low. Whichever one's turning off is then getting sent through those into the chokes, right? And then it's sent, and the capacitors come in and help send some energy to help smooth it all out. So you got the drivers and you got all of that. Now, with that said, you also have the phase right here. And usually you can count phases on a VRM by the chokes they have. Like coming back to this picture, the chokes. Rule of thumb is how many chokes there are is how many phases. As you can see here, you got 1, 2, 3, 4, 5, 6, 7, 8 phase. And then you probably got some more down here. And what the phases do is help make that current that's coming in, that chopped up current. The more phases you have, the more smooth that current becomes and the more stable it becomes. And if you're overclocking your CPU, you want more phases. The more phases you have, the more stable the system is, and the better overclocking capabilities it has. And really, that's kind of all I wanted to go over on the VRM, was just, a quicker rundown of the VRM and kind of basically what it does and why it's there. So yeah, that's pretty much it. So that's it for this video. If I missed anything or anything like that, or you felt like I could have explained some more things differently or better, leave a comment down in the comment section below. And it's a learning experience. I'm learning more, and hopefully you're learning more. So with that said, like it, dislike it, subscribe if you want, and I will have a video, I'm hoping, next week sometime. It's very inconsistent, my schedule, but that's all for now. Thanks for watching.